So, whether you're running SQL in a physical or virtualized environment, most SQL DBAs would welcome faster storage at a reasonable price. I think we can probably all agree on that. Um, Conducive's Velocity software is designed to provide exactly that, but using the storage hardware that you already own. And it doesn't matter if you have direct attached disks, or if you're running a tiered SAN, have a tray of SSD storage, or are fortunate enough to have an all-flash array. That storage layer can be a limiting factor to your SQL database's productivity. The Velocity software reduces the amount of storage I/O traffic. Excuse me, reduces the amount of storage I/O traffic that has to go out and be processed by the disk storage layer. And it streamlines or optimizes the data which does still have to go out to the disk. The net result is that SQL can typically get more transactions completed in the same amount of time, quite simply because on average it's not having to wait so much on the storage before being able to get on with its next transaction. And Velocity can be downloaded and installed without any disruption to live SQL servers. There are no SQL code changes required, and certainly no reboots. You just simply install, and typically you'll start seeing results in just a few minutes. Now, before we take a more in-depth look at that, I would like to briefly mention that last year, the Velocity software was awarded the Microsoft SQL Server I/O Reliability Certification. That's quite a mouthful for me. This basically means that whilst providing faster storage access, Velocity didn't adversely affect the required and recommended behaviors that an I/O subsystem must provide for SQL, as defined by Microsoft themselves. And Microsoft ran tests for this in Azure, their cloud platform, with SQL 2016, and they used HammerDB to generate an online transaction processing type workload. Not only was Velocity able to jump through all of the hoops necessary to achieve that certification, but it was also able to show an increase of about 30% more SQL transactions in the same amount of time. And in this test, that meant roughly 30% more orders processed. And they probably could have processed more too if they'd allowed Velocity a slightly larger RAM cache size. Now, most SQL DBAs are familiar with why split pages are bad for performance. If you've got room and your update or insert doesn't require a split, this is going to be pretty fast because SQL is just updating one page and then writing it out to disk and, of course, to the transaction log. But if the updated or inserted row doesn't fit, SQL needs to allocate a new page, move about half of the rows to the new page, and then write both pages to disk and the transaction log. So in addition, the pages in all the indexes that point to the data pages, well, they need to be updated too. So let's say that your table had one clustered index and 4 non-clustered indexes. That would mean at least 7 pages would need to be updated. You'd have 1 for the clustered index structure, 4 for the non-clustered indexes, and 2 in the data pages in the clustered index. So this page split would result in a minimum of 7 times the I/O as an insert or update that didn't require a page split. Now, each I/O that takes place takes a measurable amount of time and resource to process. And the same is true when the Windows file system splits data as it writes out to the logical NTFS volume, and that can also have significant performance ramifications. And basically, this is why forever, basically, DBAs format volumes to be used by SQL with a 64 kilobyte cluster size, rather than the default of 4 KB. It basically helps to avoid split I/O situations when writing out to disk and keeps performance-losing file fragmentation from building up so quickly. But it doesn't completely fix the problem, though. As your NTFS file systems mature over time and files are created, extended, deleted, and data's basically moved around on that NTFS volume, what happens is the free space on that NTFS volume will become more and more fragmented into smaller and smaller free space extents, increasing those split I/O situations when writing. And each time your write is split in this way, the data is being sent out to disk in a separate I/O packet. And like split pages in SQL, each I/O takes a measurable amount of time and resource to process. So in the real world, a gigabyte of storage I/O traffic that should be written in maybe 2,000 or 3,000 I/Os could now be taking 30,000 or 40,000 I/Os to complete. And we call the performance penalty that these split I/O situations cause the Windows I/O tax, as in a tax on your performance because of the split I/Os. Now, if you're running SQL in a virtualized environment, this performance penalty can be amplified by something called the I/O blender effect. And what's happening here is that you have small fractured I/O packets coming from the virtual machines, and as they pass through the hypervisor, which could be a VMware ESX or ESXi server or a Hyper-V host or KVM running on Red Hat, it doesn't really matter. But as these packets pass through the hypervisor mixes these I/O streams together, and it causes a randomization effect, so that what comes out between the physical host hypervisor and the disk storage controller underneath is now really just a chaotic mess of small, fractured, and now very randomized I/O streams that by the time they hit the storage controller, really they couldn't be less storage friendly. It means that the storage controller is only receiving data in very small packets at a time, so it now only really has the opportunity to create very small stripes across its media, and that means many more storage level operations than if the data hadn't been split as it was being written all the way up at that NTFS layer. The Velocity software helps Windows avoid or prevent most of the excess, unnecessary, performance-losing split I/O traffic, and it replaces it with far fewer storage I/O packets, each one carrying a larger payload of data. And this makes the movement of data between the server and the storage much more efficient. And it's very similar to avoiding page splits in SQL wherever possible. And it allows the disk storage to store the data using far fewer storage level operations. Velocity will also help create those nice large free space extents quietly and automatically in the background using only otherwise idle compute resource to make it easier for the Windows write driver to write into. So think for a moment of a busy freeway or motorway at rush hour. Imagine that you've got lots of cars sitting bumper to bumper with one person in each car, and none of them are getting anywhere very quickly. Hopefully you can visualize that and see the miserable look on their faces. Now imagine that each car on the motorway is a storage I/O packet, and each person in each car is your data. What Velocity is basically doing is taking all of the people out of the cars and putting them into buses or coaches and removing all of the little cars from the motorway and getting rid of all of that congestion, so that now all the people or your data can now flow to their destination in a much more efficient manner. I hope that analogy makes sense. But that's only half of the story. Velocity also introduces a RAM caching technique into the Windows operating system that further reduces the read I/O traffic that the backend storage has to deal with. And the performance benefits provided are in addition to SQL's own buffering and any caching natively provided by the Windows OS. And really, this is how we could get 30% more SQL transactions done in the same amount of time during that Microsoft I/O reliability testing that I mentioned before. Quite simply, SQL could get more work done in the same amount of time because it wasn't having to wait so much on the disk storage layer before being able to get on with its next transaction, and basically because RAM is much faster than the media in your disk storage. Oh, and it absolutely works with both physical and virtualized SQL servers, and also if you're running SQL in the cloud as well. Storage I/O reduction, optimization, and RAM caching represent a significant reduction in workload that has to be processed by the backend storage. And this is not only true of SQL Server storage traffic, but also other workload types too. So in this example on the screen, let's say the first VM is hosting SQL, and the second VM is hosting the application that interfaces with SQL, and the other two VMs are hosting busy file servers, and they're all sharing that same backend storage. Now, you might have a situation where the traffic from the file servers are taxing the performance of SQL just simply by keeping that storage layer busy. So SQL isn't necessarily the cause of the disk storage being slow, but it would likely be affected by the increased disk I/O queue depths and latency caused by the busy workloads on those file servers. So in this type of situation, my recommendation would be to install the Velocity software on all Windows machines sharing that same backend storage. That way, from the point of view of the storage, it's now simply doing the least amount of work, regardless of which virtual machine is generating the most workload at any given time. So at this point, some of you will be thinking, yes, but SQL is already using most of the available memory in the machine. How can you possibly create a RAM cache? And it's true that if SQL is left untapped, there typically wouldn't be enough RAM for conducive software to create a cache with. We've intentionally designed our software so that it can't compete for system resources with anything else that you have running in the machine, basically so that we can never be the cause of a memory starvation situation. Our software would only use some of the free RAM that isn't being used by anything else, and it will dynamically size the cache, handing RAM back to Windows if other processes or applications need it. So, for best results with SQL, you can easily cap the amount of RAM that SQL takes for its own form of caching or buffering. On busy database servers, if you can leave 16 gigabytes of RAM free, you'd have a Velocity cache size that would be enough to really make that machine's performance fly in most cases. And if you can't spare 16 gig, leave 8 gig. And if you can't afford 8 gig, leave 4 gigabytes free. Even that is enough to make a difference. If you go much smaller than that, though, then the cache size would really be a bit too small, and any performance improvements that you'd get would be somewhat limited. Now, you might also be thinking that SQL's buffering is good enough, so how does Velocity's caching complement this? And at a basic level, SQL's cache does do a pretty good job. And whilst that does, of course, have a positive impact on performance, Velocity's RAM caching is designed to eliminate the type of storage I/O traffic that tends to slow down the storage the most. And whilst that tends to be the smaller, more random read I/O traffic, that's not always the case. So Velocity uses a very lightweight storage filter driver to gather telemetry, and this allows the software to learn useful things like, what is the main application in use on a machine? This doesn't just work with SQL servers. If you've got something running MySQL or MariaDB or Oracle on Windows, pretty much any type of Windows-based database, we can usually make a difference. But it's not just limited to databases. I mentioned file servers. If you've got business information systems, ERP systems, document management systems, our software can have a very positive impact, especially where you have multiple machines sharing that same storage. So it'll figure out what is the main application that's being used on each machine, what type of files are being accessed, and what type of storage I/O streams are being generated, and at what times of the day, the week, the month, the quarter. So it can be very intelligent about what the hot blocks of data are that need to be in the RAM cache, and more importantly, when. And it can also use that telemetry to figure out how best to size the storage I/O packets to give the main application the best performance. And of course, if the way you use that machine changes over time, Velocity will automatically adapt to those changes without you having to reconfigure or tweak any settings. Validating results is really easy. First of all, you could measure the amount of SQL transactions being done each day to see if they increase. Some customers see reports that they generate take less time to produce, or SQL imports take less time, batch jobs complete more quickly. Some customers have even done a simple stopwatch test to measure things like record retrieval times. However, Velocity itself comes with very transparent reporting that will show you exactly how much storage I/O traffic it's able to eliminate from the disk storage layer. And you can see what percentage of the reads and writes are being eliminated, and it will show you how much storage time is being saved by the storage not having to process that eliminated I/O. Now, if you're using thin provisioned storage, Velocity can also help you to reclaim space. So, for example, if you're using thin provisioned VMDK files in a VMware environment, it can automatically zero out free space so that you don't have to wait for hours for an delete pass to complete. If you're thin provisioning down at the storage layer, down in the SAN, maybe it's an HP 3-pass SAN or a NetApp filer, it can also send SCSI unmap commands down to the storage controller to notify that of blocks that are no longer needed. Also works if you're using virtual volumes in VMware, vVols. If your VMs are provisioned with dynamically allocated RAM, instead of a fixed amount of RAM, such that the hypervisor can borrow some back to reallocate to some other VM, it is important to make sure that you reserve enough RAM in your SQL VM's configuration for both SQL and Velocity. Otherwise, too much RAM in the VM could become driver locked by the hypervisor's ballooning driver, and that would mean that Velocity might not get enough RAM cache to cache with effectively. Now, chances are that most of you, I'm sure, are very sensible SQL DBAs, and you've done that already. The last thing you want is for, regardless of whether you're running our software, you don't want SQL to become memory starved because the hypervisor has reallocated it to some other busy VM. Now, these are just some of the case studies that you can access on our website at conducive.com. I certainly won't bore you by going through all of these. I'll pick out one example, which is Bell Mobility on the bottom left. Bell is a telecoms company in Canada, and they saw the Velocity software reduce the storage I/O traffic to their storage, to their SAN, by 61%. Now, I'm going to say that again because it sounds too good to be true. We reduced the storage I/O traffic to their SAN by 61%, and this gave them SQL report queries that were now 3 times faster with no additional hardware required. All they had to do was install the Velocity software, which, as I mentioned earlier, is completely non-disruptive. There are no SQL code changes required, no reboots required, and really zero disruption to live running workloads. So, in terms of next steps, firstly, I would encourage you to share what you've learned in this session with colleagues. See what they have to say about this. You may find that some of them have already tried this software or are already customers and are already running it. But the simplest and best way to test Velocity is to try it for yourself with your real-world workloads. And everyone who's attending today will receive a full copy of the software from Conducive directly that's worth about £400. I would suggest make sure that you follow the best practice tips that I gave for best results. And really the important thing is to make sure that you leave at least 4 gigabytes of free RAM to cache with. That's 4 gigabytes of available physical memory that's not being used by anything else. And by the way, you're also very welcome to share the dashboard report that the software creates with a Conducive engineer like me and get additional analysis and get a written engineer's report. The emails that you can see here on the screen will get you directly connected with the lead engineer for each region. So if you're in North America, then use the first one, SRSE1 West. Mine personally is the second one. I'm the Senior Regional Solutions Engineer for the EMEA region. So SRSE EMEA at conducive.com will come straight through to me. Even if you've just got questions after the presentation, feel free to reach out. So if your organization would benefit from faster storage at a reasonable price using the storage hardware that you already own, I would urge you, please give it a try. You're not going to disrupt any live running workloads. You don't have to make any SQL code changes. Just keep running your workloads exactly the same as you are right now. And really, the whole download and installation will take no more than a couple of minutes. Use the software to not only identify those servers that cause storage I/O issues, but fix those issues at the same time. And if you want to get a hold of a copy of the 30-day trialware, where you can install it on, if you want to, all of your virtual machines, then you can get that from conducive.com/try. Now, let me throw that up in a browser, and I can show you. Let's make this a wee bit bigger. Okay, so conducive.com/try. And you'll see, oops, I've typed in the address wrong. Fantastic. Apologies for that. conducive.com/try. Let's try that. Oh, these web pages always load more slowly when I'm doing a WebEx. I don't know why that is. Probably lots of bandwidth streaming. Here we go. So this is the page that you'll see. Let me make that nice and big. So there's a little video you can watch at the top here, but to get hold of that trialware, if you want to run it on loads and loads of machines rather than using that NFR copy that is yours to keep, by the way, that's not trialware, that's a full copy for you to use on one of your machines. But if you want that trialware that'll run fully featured for 30 days that you can install onto all of your machines, fill out this form and hit the download link, and you'll get access to that within minutes and can have a play with it. And as I said, you're very welcome to reach out to me directly if you have any questions, or if you want any help setting up the trialware or interpreting the reports you get. This is my email address here again, and direct phone number. So that being said, let's have a look and see if we have any questions that have come through. So I'm going to stop sharing my screen and let's have a look. Okay, so Rajiv says, so it means it will improve I/O irrespective of hardware. Yes, because we are doing our optimization really very much at the top of the stack, at the Windows operating system layer, so that everything below that point in the stack benefits from having to deal with less workload, and the workload that it does have to deal with is now optimized or streamlined. Because we're right at the very top of that stack in that Windows layer, it really doesn't matter what the hardware is sitting below it, because we're not bypassing Windows in any way. It's still the standard Windows write driver, for example, creating a standard NTFS I/O packet and sending it out to the storage. So as long as your storage hardware is compatible with Windows, it is going to be compatible with Velocity. And the same is true if you're running in a virtualized environment. It really doesn't matter what your hypervisor of choice is, as long as it's compatible with those Windows virtual machines, which of course it will be compatible with Velocity, because we're not bypassing what Windows is doing. We're just adding an extra layer of intelligence so that Windows itself can make better choices about how it creates and deals with storage I/O traffic. So Rajiv, I hope that answers that question. Oh, another one from Rajiv. He says, and is it supported with Hyper-V? Yes, it absolutely is. In fact, we have been Microsoft Gold partners since the mid-90s. When they first brought out Windows NT 4. And at that time, we co-developed with Microsoft the Move File API that controls the movement of data around on an NTFS volume. And that Move File API is still in today's versions of Windows. You know, that's how long we've had a relationship at that sort of level with Microsoft. So, of course, it must be compatible with Hyper-V. It absolutely is. And we're also a VMware Technology Alliance partner, so it'll work with VMware hypervisors as well, whether it's ESX or ESXi. Really, the hypervisor, though, isn't relevant to velocity, which is an awful thing to say. Of course, it is, but what I'm trying to say is the type of hypervisor that you're using won't affect velocity's methodology or the way it works, as long as that hypervisor fully supports the Windows operating systems that you're running in those virtual machines. So I hope that answers the question, Rajiv. Let's see if we have any other questions that have come through. Okay, so we are using SQL Server in a cluster using always on. So is there any other setup we need to do, or is it the same for all? Now, that's an interesting question. If you have effectively an active-passive cluster set up, then all you need to do is just simply install the software and all features will work, including the RAM caching. If you have an active cluster, then again, all you need to do is install the software, but the RAM caching technology would be turned off by default in order to err on the side of caution. Okay, so you would still get benefit from having those split I/O situations avoided or prevented, but you wouldn't, in an active cluster, get benefit from the RAM caching. That would be turned off, and you wouldn't be able to turn it on. But if it's active-passive, absolutely fine. All features would be available. So I hope that answers that question. Let's see, do we have any more? Okay, so Ashley says, hi there, just to confirm, I can run this on my physical SQL server, which is an HP server with standard RAID storage. Yes, absolutely you can. In fact, Velocity does have a sister product, which we market for physical servers, which is called Diskkeeper. They both do the same job. They both have RAM caching, and they both have the ability to prevent or avoid those split I/O situations. They really share the same code base. The reason why we have the two brands is really so that we can market Velocity for virtual environments, and Diskkeeper, a lot of people remember historically, sort of way back when, as being a disk defragmenter. Well, hopefully, from what you've heard here, you'll realize that it's really moved on from just being simple defrag, and it's a lot more about performance now. But people still associate that Diskkeeper brand with physical Windows servers, so we still keep it for that reason. But you absolutely can run Velocity on physical SQL servers as well. It technically not going to be any different, and it will work just fine for you. Sorry, by the way, I should have addressed HP server with standard RAID storage. We have thousands of customers with that type of setup. I mean, HP servers, they're everywhere, as are things like Dell servers and others. And if you've got, well, we have loads of customers with things like different levels of HP 3-part storage, SAN solutions from people like Hitachi, Dell, NetApp. It really doesn't matter what media you have in that backend storage or who made it. Our software will work with whatever you have. Now, Cynthia Kumar KP, forgive me if I've pronounced that incorrectly, my apologies, says, is it something replacement of in-memory introduced on SQL Server 2014? No, it's not a replacement to it, but it can complement it, especially if you're not able to run your entire workload in memory. If you are, then great. You probably won't need to use the RAM caching other than perhaps to cache things for the operating system or anything else that you're running on the machine that in-memory processing wouldn't be able to cache and keep in RAM. But if you can keep your entire workload and process it in an in-memory style, then you're not going to see a huge increase in performance from putting velocity there and having its RAM cache there. But where we can help is by avoiding those split I/O situations when writing and subsequently reading from the disk storage layer. Because even if you're doing the majority of your processing in memory, at some point you're going to need to write data back out and read data in. So it's something that should complement that, but it isn't going to replace it, and it's not designed to replace it. So I hope that answers that. And my apologies again if I mispronounced your name. So he just said, perfect, that's fantastic, no issues. Oh, glad to hear that, excellent. So, and Rajiv says, okay, thanks, that's brilliant. Okay, so I think that's all of the questions, but as I said, if any of you want to reach out to me after this directly, I would love to hear from you. I always like getting feedback from these presentations. You know, it's always great to hear from you guys. If you have any questions, throw them at me afterwards, and I'll be more than happy to try and answer them. There's my email address and number on the screen again, if you want to make a note of that. And I am recording this session, and this recording will be made available to everybody as well. So if you want to reference some of those best practice tips that I went through earlier, that'll all be available to you. So keep an eye out for your NFR copy, that full free version that's yours to keep, and make sure you use it on one of your busy SQL servers and really see what sort of benefit you can get with your real-world workloads. Because that's the important thing. I don't want you, really, genuinely, to take my word for any of this. The best thing to do is try it for yourself and see what it can do for the type of workloads that you run. That's going to be most meaningful to you. So don't take my word for it. Try it for yourself. So that being said, I just wanted to finally thank you all for giving me the time and for being so attentive and for the questions afterwards. Yeah, we're here for you. If you need anything, feel free to reach out, and thank you very much for joining today. Take care, everyone. Ashley, you're very welcome. And Sethil Kumar, you're very welcome too, sir. And Bubbles, thank you for joining. You're very welcome. Okay. Oh, quick question from Sergey. I'm not sure if he's still logged on. How protect data by power off server? Okay, Sergey, let me see if you're still here. If not, I will make a note to email you. Oh, yeah, I think you're still logged on. So, any data that gets written straight out to the disk storage layer, just as it would as if our software isn't there. Our RAM caching is only satisfying read I/O requests from RAM. Any writes go straight out to disk. So if there is a power failure or somebody trips into the data center and accidentally pulls a power cable out of your SQL server, the data is just as safe as if Velocity wasn't installed on the software. So I hope that answers that question. Okay, I think that is pretty much, oh no, there is, no, I think that's all the questions. So I really am signing off now. Thank you very much, everyone. Take care.